we gonna weld?
Yes, we're gonna weld.
Can I get off
Not
of here?
right this second, but we're gonna weld. Okay, that's good. Violet, are we gonna do a welding machine review today?
Yeah.
What machine are we looking at?
We're working with the Everlast 2325.
The only thing we're gonna do today is we're gonna weld aluminum. Violet, what are we gonna weld?
Aluminum.
Aluminum. We're not gonna stick weld, we're not gonna MIG weld. There's a ton of videos about this out there already. So let's look at the machine, let's talk about the setup. So first of all, when we got the machine, it came in these clamshell packaging. Absolutely outstanding, perfectly damage and scratch free. A very good job on Everlast end to package the machine like this and ship it UPS right to my door. So as we take a quick look at those accessories here that are provided with the machine, ground clamp, electrode holder, adapter for smaller 8-inch spools, tip wrench, some drive rolls, a gun, and a Teflon liner. Full disclosure here, Everlast contacted me and asked me if I can make a video pulse MIG welding aluminum and double pulse MIG welding aluminum. Apparently I did some research and I didn't really see many helpful videos out there, so I tried to do my best foot forward here and show you what this machine can do and show you what we needed to do. So I'm gonna try to get some interesting stuff at the beginning of the video, and if you really want to see more so a full review, then keep watching all the way to the end. But if you fall halfway off, at least you have the key components here right out the gate. So if you're familiar with Everlast machines, here you see the model 253 DPI, Synergic single and double pulse MIG. It's a Synergic single pulse and a manual double pulse. The screen is laid out roughly how most machines are laid out, so if you're familiar with this type of machine, this shouldn't be much new. You have the option to save, I believe, 9, maybe 10 pre-selected settings and programs here. Synergic mode on and off, trigger mode 2T, which means pull the trigger, you're welding, let go, stop. 4T, which is a trigger lock. Pull the trigger and let go, it welds. Pull the trigger again and it stops. And then 4T special, this is a function for aluminum that offers you a preheat function. On the first pull and hold you have some sort of hot start. Let go, you go to weld settings, pull again, it stops. Let go, post flow stops. So at this point I didn't download the very good 60-some page manual. I mean, excellent written, very good, and absolutely must have to unlock all the features. I will refer to the manual later in the video, explain a few features here and there, but to fully understand I would really recommend that you do read the manual. And this is no surprise, and this is not any different than with any other pulse MIG machine. The pulse MIG process itself is a fairly involved, not necessarily complicated, but involved process. In order to get the most out of your welding machine, it really helps to see the manual. Every machine, the machines that I'm familiar with, more familiar with, or less familiar with, they all have different menus and individual things, how they do things. So really, to get the most out of it, reading of the manual is really essential. I don't know exactly how much hot start you have. I don't know if there's a time limit on how long you can have this pulled. I have not tried that out yet. Some manufacturers give you options of a timer controlled hot start. Other people give you options of a trigger controlled hot start like this. Some people give you both options. So this is not necessarily good or bad. This is how most welding machines work. Then you have a gas test button, which is like a perch button, wire jog to feed wire out cold through the gun or out of the feeder so you can hook a gun up. Then you have your parameter selector chart where the LEDs light up. You can go through and adjust a bunch of things. We're going to get to this later. Up here, once you are in Synergic mode, you can pick your wire diameter, 030, 035, and 045. Then you pick your wire here, steel, aluminum 4043, aluminum 5356, stainless or silicone bronze. Here on the bottom is your mode selector. You can select stick mode, MIG mode with CO2, pulse MIG, double pulse MIG, and there's a setup screen. Let's turn the machine on and see what we have.
Let me turn it on.
Yeah, Violet, why don't you come turn it on?
It's not on.
Go back here, switch the blue switch.
Okay.
All the way. So as you can hear, absolutely positively, the machine works. Cooling is assured. On this model there's no fan on demand feature, so the fan is always on maximum capacity. So that's why I did the introduction without the machine running. Now here in the synergic mode you see an amperage. You can adjust this amperage anywhere from 10 amps to 250 amps. In the synergic mode, this will not give you a wire feed rate. It will only give you an amperage rate, and it will not show you absolute voltage, I believe. It shows you a voltage deviation of the synergic curve. Some manufacturer also call this a trim function. Essentially what this does in the spray arc mode is shorten or lengthen your arc length. The negative value makes the arc shorter, positive values make the arc longer. So what that means is, if you know, for example, that you're welding 1/8 inch material, and if you know 1/8 inch material takes between 130 and 150 amps, you would adjust this somewhere between 130 and 150 amps, and your base here, your start point, would be a 0. So what this machine does, it welds, exactly. What this machine does, like every machine, it has a wire feed rate programmed with this amperage. It also has a voltage programmed, which unfortunately we don't know what this is right now. And in order to select arc length, like Lincoln Electric calls it a trim function, you adjust your voltage up or down. So if you increase this, and you can go up to +5, or you decrease it, turn it the other way, to -5, turn, keep turning. So you can adjust this, keep turning. So you can adjust it to +5 or -5. That will adjust your arc length as you're welding. So you will see, depending on how your voltage is, that it adjusts your arc length. What I found unique about this machine that other manufacturers that I found, American or European manufacturers, do not have. Typically, the single pulse frequency adjusts with other manufacturers solely and only with the wire feed rate. The voltage just is a voltage adjustment or a trim adjustment. This machine, however, also adjusts the single pulse frequency somewhat in conjunction with the voltage. Is that good or is that bad? I don't really know. It's different from everything else that I've seen so far, but apparently it works. I did some testing previous to this video on some 1/16 material, 1/8 material, 3/16, 1/4 inch, and some thicker stuff. And I found out that with 035 wire and 4043, I need to have roughly -4.5 on the voltage adjustment to get the correct arc length and to get the correct pulse frequency. The machine then welds pretty nice. We'll look at this, we'll weld, we'll look at some arc shots, we'll do some adjustments, and you be the judge. Now, I talked to Everlast. A guy, Mark there, a pretty sharp guy, he says try to play with the induction, and when you go down here on this, that is your, no, not there, inductance. This is at 10, and I think when you get the machine delivered it's at 5. So I tried this up or down. It did not make enough difference for me to change that voltage by like more than half a volt or 1 volt. So I tried it, I left it at 5. That's kind of where it's at, middle of the road, and I used the voltage adjustment to get the arc characteristics that I was looking for. So I'm in single pulse MIG now. So I will hook up a welding gun, and we'll see how it does. So the welding gun I'm using here is a 9-foot gun sourced from a different company. The 9-foot gun helps me to keep stuff a little bit nicer when it comes to feeding the wire than a 10-foot gun does. And remember, with welding, a lot of it is about personal preference. Of course, the gun that Everlast supplied works, especially if you install that Teflon liner. I prefer the gun that I use. I believe it's easier to feed the wire and maybe better gas coverage. That's just personal preference. So we're going to start out at 140 amps, -4.5 on the arc length. Hold on. And as you can tell, we had a pretty cold start here. I didn't have any hot start turned on, and the rest I kind of had to work it in like a C shape. This is still a little bit too cold for what it needs to do, so I'm gonna up it by like 20 or 25 amps and see what it does then. So now, to do the same thing, we're not going to weld the backside or anything. We use the same type of material, same temperature. Aluminum is an excellent heat conductor, and the issue is, if you start with a cold piece or a hot piece, your settings could be off by as much as 30, 40, 50 amps. So I'm going to go up 20 to 160. And this went a little bit better. This went a little bit better, but I still had to work it, and it still didn't feel like crisp and strong enough. So we're gonna up it some more and see what happens. So I'm going to up it another 115 to 175. And that's more what I'm used to. Maybe a tad too hot. As you can see, the start was still a little bit cold, and then it was a little bit too hot. It sunk a little bit too much in. So maybe dial it back like about 5. See what happens.
So in all honesty, that was the easy part. That was 4 coupons to dial in the single pulse. That's pretty reasonable.
So, and this is about what it needs to look like. 170 amps. The start is good. A tad cold. Yes, I didn't use hot start. The material also was not prepped. None of these coupons was prepped. If you watch all my other 150 videos and all the aluminum videos, very rarely do I prep anything. I'm using the same coupons like I typically use. I'm doing it the same way how I always do it. I can do this textbook too, but in reality, most people that MIG weld do not really pay that close attention to it. You can see that the frost line is pretty minimal, hardly any black soot. Gas distribution on this gun that I picked is perfect, and nice. Gas distribution on this gun is perfect. You don't see any peppering. The American-made Alphatec wire performs flawlessly. It feeds flawlessly. It's clean. No peppering in the weld. And not even really a crater crack. There is a tiny indentation in the crater, but no crack originating from it. I didn't really try to fill the crater properly either. I just ran a bead to make sure I get a nice bead.
So here you see the wire feed mechanism. It's a 4-roller, all geared, all 4 rolls driven wire feeder. 1.0U, that's for 1.0 millimeter 035 and 40 aluminum wire. So let's take this opportunity here and talk about arc length one more time. This is this famous -4.5, which I personally believe is the perfect and correct setting. You see the arc is nice, short, crisp, focused, and the way it's supposed to be. This is -2.0. If you go to negative less or even 0 or positive numbers, your arc is so long and so random and blowing everywhere that I believe that those settings are just settings that you don't want. They are not going to work for you. Also, you may get some burnbacks into the tip if the arc is that very long. Anyhow, here's a short summary of the single pulse that we've seen so far. The machine performs pretty good. If you are aware of that your zero position is not actually 0, but more like -4, -4.5, you get decent arc length, you get decent weld bead, everything runs pretty good. I'm not sure why I have to be at 175 amps. It appears to, or 170 amps for 1/8 inch material, it appears a little bit high. And looking at this video now, I can see that the display changes, the readout changes when I start the weld. I didn't notice that when I initially made the video because obviously I'm looking through the welding hood at the weld. So the single pulse is the easy peasy part. Now we're gonna dig into some double pulse and really see what this is all about and what this machine can do.
So the blinkiness of the display, this is because of the shutter speed of the camera. It's in real life, the numbers are good. I'm gonna switch from pulse make. I switched already to double pulse make. We're gonna go to 170 amps. Now typically on double pulse you need more juice than you do on single pulse because double pulse is a cooler procedure. Negative 4.7 just like we had. So here the peak of the double pulse is 200, I guess.
So the other unique thing here is, as you set your peak, you see the voltage display at 0, 0. What I found out the hard way here is you also have to adjust your trim, your arc length on your peak as well as on your background. And the peak setting and the background setting might be different. See, my finger is at welding right now. That's also a confusing thing. It says welding current, but in reality it means background because you have your peak pulse and then your welding is your background. Now the other thing is when you go into 4T special into your hot start, your hot start actually comes off the welding current, not off the peak current. So your hot start, if you don't set it high enough, can actually act like a cold start. So like I said, you have to read the manual. It's confusing. I mean, I dealt with this machine for a little bit and I looked at it and it's not really, it's just so different than anything else I'm used to. I mean, call it an operator's problem. Okay, I'll take it. It's me. I was not 100% familiar with it. I familiarized myself with it through the video and then eventually I read the entire manual and understood how it works. Again, the single pulse turned out pretty nice. It was pretty easy. The double pulse, I got it to work really well too. That adjustment range from -5 to +5 though, what's happening there is depending on what you do and how much you need, you may to do a little trick, and I'm gonna show you this like later in the video here. So by the amount of coupons on the table, you can tell that this is not my first rodeo here, but I'm getting there.
So the arc was a little bit long and erratic on the peak. So we're gonna dial this down to -5 volts.
So and this is what I was just talking about. The peak and the background, which is called welding, may require different trim, different arc length offset, and you may or may not run out of adjustments here. So pretty soon I'm stopping with this 4043 wire. I'm going into the 5356 program and I'm using a 5556 wire which has more manganese than the 5356 wire and needs a higher arc voltage. It needs about 2 more volts to melt, so that essentially kind of cheats and gives me like 2 more volts arc voltage because the wire requires 2 more volts to melt. So in my opinion, this is kind of the key position here in the video, where you see that it took me over 15, almost 20 minutes. I fast forward through all of this here to like find settings on double pulse, too hot, too cold, too sooty, too long of an arc, too short of an arc. Even though I understood the settings by now and I read the manual and I can understand how this goes. The double pulse, the full manual adjustable double pulse for sure can be nice when dialed in correctly. It's not exactly intuitive, or it just doesn't come to you. So there's a few settings and I will provide those at the end of the video that I found, hopefully to shorten your learning curve and frustration curve a little bit here. So then I took a lunch break, and then there was another 25 minutes of this going on. And I'm always up for a good challenge. I mean, there's never a shortage of me accepting a challenge. And my goal really was to show what this machine can do, to dial it all in right, and to find all the settings. And at the end, I absolutely succeeded. I found all those settings, and I will share those all with you. And take a couple more seconds watching my struggle. And the local scrapyard is really happy. I've produced a bunch of scrap aluminum in the process of figuring it all out. But once it's all dialed in, the machine welds pretty nice. So there's really no two ways about it. So again, while I'm only welding one side here, or I use the backside of a already fully cooled down piece of aluminum, is because if you want to get consistency dialing it in, you need to start with the same temperature material every time if you have the same settings. If your material temperature changes, all your settings change, and everything you thought you knew is right out the window.
So what did we learn here? We learned that the single pulse welds are pretty easy to dial in. I mean, you have to follow some settings, but it all works out. The double pulse welds are tricky. It takes a good amount to figure out what it is that you do, that you have to do, and how you have to do this.
So here's a quick shot at the double pulse. You can actually see how the drive roll and the wire roll like speeds up and slows back down during the peak and the background. So there's actually different wire feed rates going on.
Alright, double pulse. Of course I'm not gonna let you down. So I did a double pulse weld that looks acceptable. So the way how this works is I have the machine in double pulse MIG now, which is a full manual double pulse. There's no parameters to go off, there is no factory button, just press it and the machine will do anything automatically. It's a full manual deal, which apparently it has a pros. You can fully adjust it and dial it in. On the flip side, you have to dial everything in. So your welding current is really your background, which is kind of different than other guys do it. Typically you pick your peak to be your welding current, and then your background is your background. So this is your welding current, which is your background, and as you can see, the voltage offset of the synergic curve can be defined in background and in peak in different values if necessary. And what I found out is it is necessary. Here's your pulse frequency in hertz, pulses per second. Here's your pulse on time, 20% of peak, 80% of welding, of background. And I tried out 4T Special, which is the hot start function. And because your base is your background really, and not your peak, and you define how much background you want. So now when you go into hot start, it makes a hot start off of the 66 amps, not of the 200 and some odd amps. So actually the hot start is colder than what you're welding with in the double pulse. And the single pulse,
the hot start is adjustable though, and I did not adjust it correctly.
Here is a little bit strange. So I switched to the 5356 program. I loaded 5556 wire, which is a has a higher manganese content. It has magnesium just like the 5356, but it also has manganese in there. What that does is it requires 2 more volts of arc voltage to run. When you look at this here, I'm at negative 3.8. If I take 2 more volts out, I would be at negative 5.8, which the machine only goes to negative 5. So in order to make work with that adjustment range, I loaded a wire that requires more voltage, so now I'm in the adjustment range. 0.45 diameter, that's what I got loaded. So now let's go back to 2T and let's see if we get an arc shot on this.
As you can see here, it's a very nice, very controlled, almost spatter-free arc. Once it's dialed in correctly, and once I picked the alloy that I found suitable for the voltage adjustment range that was given to me, at about 45 CFH, 100% argon, with all those settings I just gave you, it ran beautiful. So, and then I ran multiple tests on pieces that were ice cold, pieces that were like somewhat warm, and pieces that were warmer, just to fine tune it and get all the kinks worked out. And I ended up with some pretty serious, nice Ripley double pulse welds. So here in comparison, you hear the sound is different, it looks different, the arc is white. This is the 4043 in 0.35 diameter again, and you can tell when the peak pulse comes in, you see how the arc becomes long all of a sudden. There was not enough adjustment there to keep the arc length the same during the peak and the background. I mean, it does make for an okay weld, but it's at the limits of what the machine can do. So of course here I did multiple shots too, on like different material, temperature, and different configurations, trying to figure this out. I actually played with the inductance too, from 1 to 10 and anywhere in between, and I really could not verify that adjusting that inductance on my machine made a groundbreaking difference. So for the most part I left it right at 5 and just call it a day. So my personal mission was to show that the machine can weld single pulse and double pulse, and that it can make great welds. And you know what? The welds, here they are. Do they look great? I believe they look at least good or very good. If they look great or not, it's up to you to decide. The only thing I tested on this machine was aluminum pulse MIG and double pulse MIG welding. I never welded any steel. There's some great videos that Weld.com did with Bob Moffat, who welded steel with the machine. Also in pulse spray arc. And if the machine is any good or not, if it does the test of time, I don't know. I have about 20 hours of arc time on this machine under my belt. There's other machines that I welded with for like 3 years and ran like dozens and dozens or hundreds of rolls of aluminum wire through. This machine here, if you're interested in it, buy it, try it out yourself, see what it does, see what you can do with it. It's definitely possible to make good welds with it. Apparently there is a push-pull gun and a spool gun available, which I did not have the opportunity to test any of those. I really wish there was a remote control function. I did not see any on the machine or in the manual described. So that really would help with heat input as you weld larger pieces of aluminum, and you can do like I did here, keep a constant temperature going. But all overall, I mean, give it a shot, try it, and see if you like it.